Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a problem from section 7.1. This is problem number 2. The problem says we have an amount of syrup that people use or that people put on their pancakes is normally distributed with a mean of 64 milliliters and a standard deviation of 13. Suppose that 42 randomly selected people are observed pouring syrup on their pancakes. Round the answer is up to 4 decimal places where possible. So they want the distribution for X, the distribution for the mean, and then they want a couple of probabilities, and then they want to know if the assumption is necessary for, if the assumption of normality is necessary. All right, for the first one, let's do a little bit of work on the side. We have the normal distribution. If we have an X as a normal distribution, it's going to be normal. We want the mu and the sigma associated with that. And that would be what we would get. And we know our mean and standard deviation for this particular problem, the mean and the standard deviation for this particular problem. So that's pretty straightforward for the first part A, 64 and 13. For the second part, if we want the distribution for the means of the samples, then this is going to be a normal distribution, and we're going to use the same mean as before, but the standard deviation will be divided by the square root of n for the sample size. This, by the way, usually has a subscript of x to say it's a subscript of the x, the original, and then when we're talking about the mean for this, it's going to be these things. We'll do the computation and we'll put that in a little bit later. So now the next problem, well, I suppose we could do it now. Let's pull out our Google Sheets, which is what we're using. And we know that the mean is 64 and the standard deviation is 13 and the sample size is 42. So the new the new standard deviation, also known as the standard error for the mean, is going to be the sigma divided by square root of n. So the old sigma, which is 13, divided by square root of 42. So here I'll just say equals, and then since I have these values, instead of typing them in, I'm just going to click on the cell. So that's going to be a value of 13. And then I'll divide by the square root of this number, 42. And then looks like my answer is going to be 2.0059. Round out to 4 decimal places, 2.0059. All right, so same value for the mean, and then a new value for the standard deviation for this new thing. All right, our next question is asking us to find the probability. And we're asked to find the probability for a single randomly selected individual. So this is the single selected individual, which means your mean is the original mean and your standard deviation is the original standard deviation. And remember, for Google Sheets, when we're looking for the value or the probability, which is the same thing as the area between these two values, we have to subtract one from the other. And I'll choose the bigger one. One note here is that the 64 is the same as the mean, so I know that the probability of being less than or bigger than 64 is going to be 1/2, but let's not worry too much about that right now. So I'll say this is going to be according to the Google Sheets command, it's norm.dist, and then we're going to put the value 64, and then we're going to choose this mean, which is 64, and then choose the standard deviation, and then enter true because it's going to be cumulative. Now that's going to be the cumulative distribution up to 64, but we want to take away the cumulative distribution up to 62.7. So norm.dist, and then we enter 62.7, the same mean 64, the same standard deviation 13, and then the same cumulative true. All right, so that's going to be our input. Now if we go ahead and find that in our program, we are looking for the probability that our x value is between 62.7 and less than x less than 64. And then that's going to be the norm.dist, and then we put in 64, and then our mean is 64. It's already here, so I'm just going to start clicking 64, comma, and our standard deviation is 13, comma, and then we want this to be true. And then notice if I stop here for a moment, the answer is 0.5, which is kind of like what we anticipated because this is the very middle. And then we're going to subtract out norm.dist. And then here we put in a 62.7, comma, and then we select the same mean, comma, the same standard deviation, comma, and then true. And then we're going to get this value, which is 0.0398. So we get 0.0398. All right. Now the next one says for a group of 42 pancake eaters. For a group of 42 pancake eaters. So our notation here will be a little bit different. And we have the same values seemingly. For between 62.7 and 64. But instead of putting just a regular x, this is the mean that we're looking for. So there's a difference, and slight difference in notation that we have in that we're looking for the mean values. So this is where we invoke the central limit theorem, and we'll have the same mean, but we'll have a different standard deviation to put in. Okay, so in general, our command will be almost the same. Norm.dist, and then 64, 64, 13, well, not 13. So this is where it's different. Instead of 13, we're going to put in this value, 2.0059, and I probably don't want to just put this this number rounded off to 4 decimal places. I probably want to put more here, and what I'm going to do is I'm going to rely on the command to take care of that for me, or better yet, I can just put in what that was, which is the original standard deviation divided by the square root of 42. And then we'll put true here. And minus the same thing, norm.dist. And then 62.7, 64. And then again, the change here is 13 divided by the square root of 42. Of course, you would type in SQRT and then true. All right, so let's go ahead and put that in our Google Sheets program. And it's kind of hard to put the bar here, and so I'm just gonna say X bar just to get this notation, and then equals. So I'll type norm.dist, and then I have 64 comma the mean. Now the standard deviation is not 13, but instead it's 13 divided by square root of 42, which we actually computed here. So I can type 13 divided by square root of 42, or I could just click on this number and that'll automatically get that figured out. And then true. Again, the answer here is 0.5 if I stop here, because that's exactly the same as the mean and you're looking at just half of this. But we want to subtract out norm.dist, and then here we have a 62.7, and then the mean is the same. The standard deviation is a standard error of estimate, and then true. And then notice that we get a different answer here. It's 24,2415, and then there's a 3 there, so we keep 2415 as our rounded off to 4 decimal places. So 0.2415. Okay. Assumptions for the distribution. Do we necessarily assume that it's normal? With an n size of 42, we don't need to assume it's normal. The central limit theorem guarantees that it'll eventually become normal. So I would say no for this one. CLT, central limit theorem, with n equals 42. This is anything over 30 is usually considered large enough that you don't need to assume normality. No need to assume normal. Okay. All right. So we have our inputs here, and then so they're making a good point here in a sense that we have the same numbers for your probability between 62.7 and 64. But one of them uses the original distribution while the other one uses the mean distribution, the mean of the samples distribution. And so that's where it makes a difference in your responses. So your standard deviation changes from one problem to the next. All right, I hope that helps. Good luck.